So it wouldn't be as dramatic as, let's say, two different Spider-Man or two different versions of the Flash. It would just be one quantum physicist and another version of that same quantum physicist, everything identical except the subtle difference of seeing a blip on a very tiny, tiny distance away on a screen. And once again, I mean, that's a little weird to imagine bifurcation, but that's not something we directly experience. We would never know about it. It would happen naturally, and it would happen in this abstract space called Hilbert space. So it wouldn't really affect our lives. It would just mean that we would have different, quantum results.
Okay, joining me on the freedompact podcast today, I have Paul Halpern, a professor of physics at St. Joseph's University and the author of 18 popular science books, including the one we're here to talk about today, The Allure of the Multiverse, Extra Dimensions, Other Worlds, and Parallel Universes. Well, Paul, welcome to the freedompact podcast.
Thank you for having me on, Lewis.
It's an absolute pleasure. One thing I'd love to start this with, I was watching a show the other night called The Big Bang Theory. I'm sure you're familiar with it. And there's a joke in one of the earlier episodes where the female character says to the main protagonist, "So, what's new in the world of physics?" He says, "Nothing." She says, "Really? Nothing?" He says, "Aside from string theory, since the 1930s, there's really been, no new developments. And outside of that, all you can say is my idea is quite credible. But I have no hard evidence for it." In terms of this topic we're here to talk about today, the multiverse theory, is there any hard evidence or any good research, sound research that's come out in the last 10 years that justifies the uptake in interest around this subject? I'm sure we'll go on later to talk about, how this has become such a sort of popular topic in media and pop culture. But is there anything that's really triggered this in terms of the science and the research?
Well, I would kind of update or kind of explicate your comment about the Big Bang Theory comment because I would say that since the 1970s and 1980s, there hasn't been as much progress in
Mm.
physics, and I think people are frustrated because they want to develop a theory of everything or a theory that unifies the forces of nature, and there are some major problems in theoretical physics involving discrepancies. For example, gravitation is much weaker than the other forces. Um, and Also, it hasn't been able to be quantized. So there are these issues, and that's why people turn to string theory to try to address some of these issues, and membrane theory and so forth. But once you turn to some of these theoretical ideas, then there's some loose ends. And the popularity of the multiverse ideas among some theorists is to try to tie up the loose ends and to try to say, okay, let's think out of the box. Let's try to come up with an idea which will narrow things down and explain why the universe is the way it is. For example, the constants of the universe match up with, theoretically match up with values that we see today, which are necessary for life. Um, and Something called the anthropic principle, which is one form of the multiverse, says of all the universes out there, this is the key one for life and planets. Other ones would not develop life, as we know it. So that's why we're here. And that's an interesting use of the multiverse.
Yeah, and something you mentioned there, I'd like to pick up on in a moment if I can, and that is the loose ends that this does tie up. But just before we get there, a bit of background on this multiverse. Now, the term multiverse, I didn't know this until I read your book. The term multiverse didn't originate in the world of physics, but philosophy, right?
Yeah, so William James talked about a moral multiverse, something that a universe which is morally ambiguous, that it doesn't really value or favor good or evil, but kind of is indifferent to those. And that term was used in the late 19th century. And then the term was picked up by science fiction writers and then kind of eventually physicists to try to describe all of the different models in which you have parallel universes, starting with the many worlds interpretation, which was proposed in the 1950s, but not really popularized until the 1970s. So the 1970s was when interest in these parallel universes verse ideas started to grow. And then by the turn of the 21st century, by 2000, a lot of theorists started talking about multiverse ideas, including the late Nobel laureate Steven Weinberg. And so it's really been a 21st century phenomenon.
Now, I know a lot of people who may be listening or watching this, they may be thinking, the multiverse, they might not be able to wrap their head around this and think that this is very grandiose thinking, this is highly speculative. Now, I'm not sure if you're familiar with the work of Dr. Stephen Meyer. I've spoken to Dr. Meyer on this show, and I was talking to him about the idea of the multiverse. And he said that, in his opinion, it takes more faith to believe in the multiverse than it does to believe in religion. And he described the multiverse theory as mathematical castles in the air. Would you agree with that sentiment?
Well, it depends on which version of the multiverse one is talking about. For example, there's one version of the multiverse which is also known as eternal inflation. And, and the inflationary universe theory is pretty well accepted. It's an idea that shortly after the Big Bang, the universe expanded very rapidly, ultra rapidly, because of some energy seed, a scalar energy field that triggered ultra rapid expansion. And that expansion explains a lot of things. It explains why the universe is so smooth. So that if you look in all directions, you see pretty much even temperatures in the cosmic radiation background. It also explains why galaxy counts are pretty similar in all directions. So everything is very even in the universe, and inflation levels things out, evens things out. It's a bit like stretching a sheet in all directions, and all the wrinkles are removed because you're stretching it and it flattens out. And so a lot of people in cosmology believe in an inflationary era, and there's even some evidence for it in the cosmic microwave background, the profile of it. But then, as Andre Linde showed, inflation is incredibly easy to produce. So if it happened once, it would happen again and again. And there's no reason to imagine that inflation only happened one time. In fact, inflation theorists say it would be very hard to propose an inflationary model that only happens once, but it's very simple to propose an inflationary model that happens endlessly. And that suggests multiple versions of the Big Bang, multiple versions of cosmic expansion. And if you take that seriously, then that means that there are all these other universes out there that were produced from seeds in a similar manner to ours, and we just don't access them. And that's a version of the multiverse that I think, I mean, it might be hard to prove, but it's very palatable because it's kind of logical. If this you see this energy field profile one time, why not see it other places? And so I think that's not really castles in the sky. That's hard science.
Now, I know for a lot of people listening to this podcast, they will come on a journey with me every week and they will listen to episodes that they may know nothing about. They may have no background to it. This may be a brand new concept to some people. So I want to try and clearly define things as we move along for people who aren't already, don't already have an understanding of what we're talking about here. If you were to give a quick elevator pitch on what we mean when we're saying multiverse, what would that elevator pitch look like?
So multiverse is everything that lies beyond direct observability, is in my opinion. So basically, the universe, a segment of it is observable, but not the whole thing. The universe could very well be infinite. We don't know. We can only see out to 46 billion light years away. Uh, so, so that's one area where we can talk about the possibility of other enclaves that are like our universe, but are out there that are not really connected with our universe, don't really have an impact. So we can call them, other enclaves, or you can simplify that and say a multiverse. Now, multiverse for some scientists has a connotation of science fiction. So not every scientist likes the term, but it's a quick way to explain something that's beyond direct observability. Similarly, in quantum physics, you might have a quantum state that's a superposition, meaning a mixture of possibilities. And we might see one possibility, but there's an idea called the many worlds interpretation of quantum mechanics that versions of us in an abstract space might witness other possibilities. And the differences could be subtle. So we could see, a blip on a screen representing an electron being 1 nanometer from some mark, and another version of us might see it 2 nanometers away, as just because the electron's quantum state might be spread out over multiple possibilities. So it wouldn't be as dramatic as, let's say, two different Spider-Man or two different versions of the Flash. It would just be one quantum physicist and another version of that same quantum physicist, everything identical except the subtle difference of seeing a blip on a very tiny, tiny distance away on a screen. And once again, I mean that's a little weird to imagine bifurcation, but that's not something we directly experience. We would never know about it. It would happen naturally, and it would happen in this abstract space called Hilbert space. So it wouldn't really affect our lives. It would just mean that we would have different, quantum results. On the other hand, it would rescue quantum theory from one of the problems it has, and that's the measurement problem, where if you need, in some versions of the measurement problem, you need a human being to take a measurement, and then the system collapses down into one value. In this case, there's no quantum collapse. Everything stays the same, and we're part of the picture. We're part of this ever-evolving quantum state. So, and this is a little bit controversial. There's a handful of theoretical physicists who say this is absolutely right, this is reality, accept it. And then there's some who say this is not science at all, this is science fiction, don't even talk about it because it's not even science. There's an expression from the physicist Wolfgang Pauli, the late physicist. He said, this theory is not even wrong. And some people say that about the multiverse. It's so unright, it's so untruthful, so unscientific that we couldn't even say it's wrong or right. It's just nothing. And then there are people in between, and I would fall in the in between category, who say, look, it would be better to come up with a objective explanation for this quantum phenomena that doesn't involve these bifurcations. But what if there's no other choice? Why not accept a simple solution that's not going to affect our lives? We're not going to experience this. It's just a solution to a problem.
So I'd love to ask you because this book is it's neither a case for nor against. As the title suggests, you're simply exploring the allure of this subject. Now, to have written such a fascinating and detailed book on the subject, there must have been something that was compelling enough to draw you to put that effort and time in. So for you, someone who operates within this space on a daily basis and really understands the science behind it, because there'll be many people, much like I will admit for myself, when I read books like this, I think to myself, I very barely grasp what is being said most of the time, and it's a subject I wish I understood more than I actually do. But for someone who really understands the science, like yourself, what is the most compelling argument you have heard that has drawn you to this subject?
Well, so I became interested in the idea of alternatives, uh, both in literature, science fiction. When I was a child, I read a lot of speculative fiction, science fiction authors like Isaac Asimov, Ray Bradbury, Arthur C. Clarke, and so forth. And then when I became a physics PhD student, I took on a topic which was alternatives to the Big Bang. And it was kind of a fun thing to calculate mathematically. And I went to, for a few weeks, he wasn't my supervisor, but I went to um, University of Sussex in England and worked with Professor John Barrow. And he told me, well, it's possible that in a chaotic cosmology, that our universe started out very different. It could have been very irregular and evened out. And that's what we're exploring with these ideas. And I thought that was a very interesting argument that maybe the universe started out very odd, very unusual, not expanding the same in all directions, but maybe, expanding at different rates in different directions and somehow smoothed out and got evened out by some process over time. So that's what I explored in my thesis. So that got me thinking about alternatives. And I've been thinking about that in my whole research career, alternatives to the standard model that still fall within theoretical physics. They're still valid theories, but a little bit offbeat, a little bit different from what is being talked about. And then in recent years, I heard a lot about multiverse movies, Doctor Strange in the Multiverse of Madness, the Spider-Verse movies, and all of a sudden there was a lot of interest culturally in the idea of a multiverse. And I was thinking, I know a lot about general relativity, these alternative models. I've studied about some of these. I could learn about the ones that I didn't study. And I thought it would be very interesting to introduce readers to the science behind the multiverse. And as I developed my book, I realized that the science is very different than what's depicted in the films. So you don't necessarily walk through a portal and meet your doppelganger and who's instead of being, really nice interviewer is evil or whatever and is uh, you know, out to take over the world. It's something that doesn't happen in science. In science, you might you wouldn't walk through a door and meet another version. They'd be in a different space altogether, a different abstract space. So you would never meet, and there'd be subtle differences. Or in the cosmological idea, if there was another version of us, they'd be so far away that you couldn't possibly ever contact them. They'd be, trillions of light years away. So you would just have to kind of think, oh, I wonder if there's another version of me out there somewhere in an infinite universe. But it's something to speculate about, but it's not something that would really, affect our lives.
One thing I see crop up again and again, and this is something that is really big on social media and in more popular science than actual hard science. But whenever I see people talking about alternative theories, there's one experiment seems to pop up every time, and that's the double slit experiment. This idea that atoms behave differently when observed. What significance does that experiment actually tell us? And do you think people get carried away with what that could possibly mean, and they sort of interpret it in the wrong way?
Well, the interesting thing about that experiment is it's kind of a standard experiment for a physics major in pretty basic courses. So it's something that we're kind of used to as physicists. Um, just the idea that something like an electron behaves in some ways like a particle and in some ways like a wave.
Hmm.
And waves have this phenomenon called interference. So if you shine light through two different slits, the light breaks up. And since the light is a wave, when it comes back together again, the waves can line up,
Yeah.
in which you get a bright line, or they can counter align. So the peaks and the troughs are lined up. It's a peak with a trough. So then you don't see anything. And then it's a dark line. And the
Hmm.
same thing happens with electrons. You get this interesting interference pattern with the double slit experiment. But if you run the experiment another way, if you cover one of the slits, then you don't see this interference pattern, similarly to what would happen with light. So it's pretty basic to physics majors, but it's surprising to people who don't know that particles can also act like waves. And one of the last people who asked me this question was, interestingly enough, not to name drop, but I've interacted with a rock star, Roland Orzabal of Tears for Fears, who
Yeah.
has this deep-seated interest in quantum physics, and he was asking me at a after a Tears for Fears concert. Uh, he was kind enough to invite us backstage and was asking me about the double slit experiment, and I was trying to convey the importance of it. But then I was like thinking, well, this is a pretty standard experiment for physics majors. But then I was thinking from his point of view, it was very surprising that a particle would act like a wave. So I was really flattered that he was asking me that.
Wow, what a name drop. I love it. Yeah, it's almost the sort of go-to experiment for an armchair physicist. The people that probably wish they could understand it better than they actually can, like myself. When you were talking earlier about some of the quandaries that this tends to help people fill in the blanks, it reminds me of like a magic number for accountants when they can't get the books to balance. They've always got that magic number that only means something to them that can just magically balance the books. What quandaries in quantum physics does the multiverse theory or the many worlds theory help make sense of?
Well, fundamentally, it helps us understand why the quantum world is different from the mundane world, the classical world. And the quantum world is very fuzzy. So in the quantum world, an electron might be smeared out over multiple positions. So because it's fundamentally a wave.
Hmm.
So just like an ocean wave, you wouldn't see an ocean wave at a single point. You might see it spread out over a distance, little distance, not over the across the whole ocean, but a small finite distance. The same thing with electron, be spread out over a small finite distance. But then, strangely enough, in quantum physics, you ask the question, what is the exact precise position of the electron? And you do an experiment that forces the electron to project on a screen, and you measure its exact position. And then once you do that experiment, somehow this wave function, as we call it, collapses into a single point and you get a single value. And the way that's modeled is a two-step process where you have the first step is kind of a continuous evolution, and the second step is human-induced collapse, where someone takes an observation, and if it's a position observation, it collapses into a single position value. If you're observing its speed, it collapses into a single speed value. But you're not able to do both because of Heisenberg's uncertainty principle. You couldn't measure its exact speed and its precise position at the same time. So these are mysteries, and one of the big mysteries is, why should humans be in the picture? After all, humans are made of atoms, and nature should work perfectly well without humans. And that's when why a young physicist, Hugh Everett, who was in a PhD program at Princeton, proposed the idea that became known as the many worlds interpretation. He said everything should just keep going in a giant universal wave function, and that humans must be part of the picture, that we're part of the same smearing. So we're smeared out across possibilities, just like an electron is smeared out across possibilities, but we just don't realize it because um, our conscious experience only goes along one of the branches. Um, and it would be a clone of us would have a different conscious experience that bifurcates into to a different branch, but we would never meet up. So That's the question he was trying to address. And he proposed the idea to the great quantum theorist Niels Bohr of Denmark, who was almost like Danish royalty at the time because he was so famous. Um, when Queen Elizabeth visited Denmark in the 1950s, she paid call on the royal family of Denmark and Niels Bohr, the quantum physicist. So he was in
Wow.
that category. She came to his mansion, which was funded by Carlsberg Brewery. They gave him a lavish mansion, so he was doing very well. He was, you know, as I said, like royalty. And then here this young upstart comes along, this 20-something-year-old, and says, "Well, I have this idea which is completely different than yours, Professor Bohr. I think that human beings should be part of the picture. You shouldn't, you know, have a role of the observer." And he paid absolutely no attention to the young student, Everett. He just ignored him. And Everett was completely mortified and decided to go into the defense industry, and he quit theoretical physics. And only later in life, another physicist, Bryce DeWitt, publicized Everett's ideas, and Everett, DeWitt came up with the term many worlds, and he um, helped co-sponsor a conference at Texas in the 1980s, and Everett was invited to give a talk, and it was his triumphant return to to talk about his theory, which at that point, by the 1980s, more people believed in it, and he was happy that people took interest in his theory that was essentially ignored between the late 1950s and the mid 1980s.
Wow. That is extremely interesting because that feeds into something I was going to ask you about. And I know you already touched on it, but what are the politics in academia like around a topic like this? I can imagine, there are probably some academics that would be willing to write somebody off just for contemplating this idea or spending time on this idea where they could be spending time elsewhere. Is this quite a political subject in the academic space?
Well, at best, they're fist fights. At worst, it's scarier than that. But you know,
Wow.
seriously, we tend to be pretty civil. But then, if academics want to be insulting, there are ways they can do that. Uh, seem to be falling asleep at a talk, and then all of a sudden get up and say, "That's absolutely wrong." So, but there's some academics who are very much appalled by the idea of the multiverse. For example, Paul Steinhardt, who was one of the pioneers of an inflationary universe, and he's a respected Princeton professor, and he has an alternative to inflation called the cyclic, or some people say cyclic, cosmology, and um, and that involves multiple copies of the universe, but not bubbles, but actually in a higher dimension that crash into each other periodically. So that's also a little bit out there, a little bit weird, but he doesn't like the idea that there are all these bubble universes and that it means that our universe is insignificant and there's no reason to single out our universe compared to other universes. So he wrote, along with Avi Loeb and other physicists, wrote an editorial in the American Journal, Scientific American, saying that we should stop thinking about multiverse ideas because they're not scientific. And then Andre Linde, who, as I said, proposed eternal inflation, and a number of other physicists said, "Hey, wait a minute, this is inflation is very respectable, and the implication is that it's eternal and that there are all these bubble universes out there, and there may be ways of proving this." For example, some physicists are looking for collisions between these bubbles and trying to look for scars of the collisions
Wow.
and to try to prove that they're out there. So Linde and others say, no, this is not nonsensical. It's real science. We have to take it seriously. So that's really the battle. The battle is in editorials, in the pages of magazines. So it is pretty tame, but
Yeah.
it's more fun to imagine something a little bit wilder in terms of the battles.
Definitely. You mentioned bubble universes there. Actually, I mentioned this is a subject I would love to be able to understand better than I do. A couple of weeks ago, I went to see Brian Cox, famous physicist here in the UK, give a lecture in Cardiff actually, and I was following along, and it was quite simplistic because it's a popular science talk, and I was thinking, okay, I'm following along. Okay, I understand that. I thought I'm doing pretty well here, and then he got onto the subject of bubble universes, and I just went, it it completely it just took me to another space. I could spend a lifetime trying to wrap my head around the science behind that. But
My yeah, my response to Brian Cox is Manchester does football well, Manchester does music well, so why not? It also does physics well. In fact, it's one of the leading producers of Nobel Prizes in the UK. So,
oh
and that's where Brian Cox is from. You probably
yeah,
know.
oh
Yes.
absolutely. Have you ever had, come into contact with Brian Cox?
Well, just virtually, we
Yeah,
we've interacted on what used to be known as Twitter, now
yeah,
X. But
amazing.
he's seems a very friendly person, and I enjoy his videos, especially there's a brilliant video of him with Stephen Hawking from some years ago. I would encourage people to look up, which from actually from Monty Python reunited at the O2
Yeah,
Arena, and then they showed a video of Brian Cox uh, criticizing the song, the Galaxy song by Eric Idle, and then Stephen Hawking runs up to him in his wheelchair and runs and knocks Brian Cox over. It's really fun if for those of you who haven't seen it.
it, so with people like Brian Cox, and this is something I spoke to Neil deGrasse Tyson about when I had him on the show last year. We were talking about the importance of these figures who are able to take a subject like this and make it as digestible as possible to the everyday person that has no background in this. And I think again, you do a great job in all the popular science books you've written. These are really important books to be putting out there because there's so many people out there like me that are fascinated by these ideas, and when they're digested in such a way, I think is so important. So Neil deGrasse Tyson was saying like the world needs more people like a Brian Cox, who hard academics, hard scientists may say, may question, oh, how much research has this person put out? What have they contributed to the field? But just by doing what they do in the media, in pop culture, it adds so much more to that field than you could imagine. Would you agree that we need to see more people in the world like a Brian Cox and Neil deGrasse Tyson?
Oh, the popularizers are great and they're really important, and also they inspire young people. And
Yeah,
Neil deGrasse Tyson, especially here in the States, I don't know about the UK, but he inspires so many children to go into science. And a lot of times I'll ask a child or a high school student, like, who is your scientific hero? Neil deGrasse Tyson.
yeah.
Now, here in the US, we're not as familiar with Brian Cox, but I'm sure in the UK, he's inspired many young people to go into science and, you know, or combine science and music, as the case may be.
Yeah, no, absolutely. I think Brian is the UK's Neil deGrasse Tyson. So
Yeah.
we both have great popularizers, as you mentioned there. Um, the one reason why I'm sure that there's so many multiverse movies and TV shows now is that for me, I love them because it gives me a chance to, I mean, take the latest Spider-Man No Way Home. It gave me a chance to see my Spider-Man, Tobey Maguire, who I would never thought I would see in a movie again. He's come back. So I understand it from that commercial aspect. It's a really easy way to jam actors together that you would never really see together in any sort of storyline other than that. So that makes sense to me. But outside of that, why do you think there has been such an uptick in multiverse movies and multiverse TV shows and episodes exploring that concept.
Well, multiverse movies in general explore the question of what if and alternative realities. And I think these are of interest to people because everybody makes decisions in their lives. Like, somebody might decide between taking up a job in Cardiff or taking up a job in London. And, they might wonder, like, what would happen if, I made the other choice? How would my career go?
Yeah.
And there's a great film that I would highly recommend from the 90s called Sliding Doors, where a woman played by Gwyneth Paltrow misses a tube train and she doesn't find out that her boyfriend is cheating on her because she arrives back to her flat too late and she misses the affair. But then the camera kind of all the filmographer shows another version of the same story where she just makes the tube train and she arrives at her flat, sees her boyfriend cheating. She breaks up with him and meets the man of her dreams, and and changes her whole lifestyle and gets a new job. And then the film continues, and you see both alternatives. And then I'm not going to give it away in case you haven't seen it, but there's kind of a twist at the end, you know. So so that is to me the quintessential multiverse movie, which shows you the parallel strands that one's life can take. And everybody wonders, like, what would happen if they went to a different town
Yeah.
or they took on a different job or met different friends, had a different relationship. And we don't really have the capacity, and not even science offers the capacity to look in some strange television set and see all these alternative lives that we live. But we still wonder about it and we still talk about it.
Yeah.
And sometimes if you're in a relationship or a friendship, you say, isn't it so lucky that we were in, the same pub or the same cafe at the same time and ran into each other. So people kind of think that, the decisions they make or even chance happenings are like the best for them, but you just never know. So that's the fascination. And it's interesting to see what would happen if Spider-Man grew up, in a different circumstance, a different neighborhood, got bitten by a different radioactive spider, and so forth, you know, and what would have happened to that spider? So
Yeah.
there's a lot of big questions there.
No, that makes so much sense. And I'm sure you've seen a few of them just in, the research you did for this book. What is in your opinion, your personal opinion, the best multiverse themed film or show you've ever seen?
Well, funny that you asked that because I actually have an article I don't know if I'm allowed to plug it, but a prominent UK science magazine that starts with new and ends with scientist. Uh, I guess I can mention it, right?
Yeah, of course, absolutely.
You're your key competitors, but
Yeah, no, please, please.
I'll give them a plug.
Yeah.
Okay. So the other place you see science aside from this podcast, the New Scientist, they were kind enough to invite me to write a column. I'm not sure if it's in the paper version, but I know it's in the online version.
Wow,
The top 10 films about the multiverse. So I
amazing.
included films such as The Matrix, Sliding Doors, Back to the Future, Everything Everywhere All at Once, um, Groundhog Day, and even It's a Wonderful Life, which is a sentimental film about what would have happened if the main character hadn't been born. So there are a lot of films out there. So it's called, surprisingly enough, the top 10 movies about the multiverse.
Does what it says on the tin. I
Yeah,
love
yeah,
it.
exactly.
Well, no, absolutely. And in fact, that I will go and find that and I'll include that in the show notes below so everyone can check it out because I think that would be a really fun thing to include and I certainly want to go and find it myself. So I'll include that as well. Please tell me you've seen the show Rick and Morty.
Oh yes, and I mentioned it in my book.
Yeah, of course.
And You know, they jump from one parallel to universe to another on every show practically.
Yeah.
And it turns out Rick and Morty, we didn't know this, or that the characters we watch are actually from different parallel universes. They're
Mm.
not from the same universe even.
Yeah.
So yeah, I'm a fan of that show.
Do you find it? And I know a lot of spoken to a lot of academics and scientists who have very different opinions on this, but for some, it seems like when I spoke to Neil deGrasse Tyson, he said he has a hard time watching science fiction movies without sitting there and wanting to sort of analyze the science or analyze the theory behind the movie. But likewise, I've spoken to others that say they completely disconnect, movies from having to analyze and scrutinize every little bit. Where do you sit on that? Are you able to sit and enjoy a movie for what it is, or are you the type of person that's watching the film Gravity and thinking, well, that doesn't make sense?
Well, it depends on how the film is billed, how it's marketed. So if a film says this film is following science very closely, then sometimes I look with a bit of a jaded eye. Or if it's a biographical film where they depict scientists, like Oppenheimer, um, the character who played Oppenheimer, the actor who played Oppenheimer was brilliant, but
Killian Murphy,
um,
yeah.
right, but then there were some side characters, lesser characters, like Niels Bohr. He was depicted as being this very strong-minded, loud-spoken individual who was very assertive. And in reality, Niels Bohr mumbled. People had a lot of trouble understanding what he was saying, was very quiet, was very absent-minded. So, I know that they couldn't have possibly looked into every character, but, I felt like the movie wasn't really true to in its depiction of Niels Bohr as much as it was of Oppenheimer, for example. So that's where uh, I kind of, if especially in cases where I met somebody and I see an actor trying to depict them, then I'm kind of like, oh, wait a minute. Like, for example, there's a film a few years ago about a biography of Stephen Hawking, and I'm blanking on the name, but it was a major biography of Stephen
Oh,
Hawking.
was it a film? Was it The Theory of Everything?
A Theory of Everything,
Yeah.
yes,
No, yeah, I've
exactly.
seen that film, yeah.
Yes, thank you. So anyway, they have Hawking meet Roger Penrose,
Yeah.
who's an Oxford physicist. I don't know if he's been on your show,
No, it certainly
but
hasn't.
anyway, and I've met Penrose a few times and
Wow.
interacted with him on uh, a Zoom for there was a virtual conference and so forth. So I know exactly what he's like. And then the actor who depicted Penrose in the movie, I just thought that's nothing like Penrose.
Hmm.
Um, but the same thing with concepts. If somebody says, "Oh, this is a very realistic portrayal of a black hole," but then if something seems a little weird or off, then I'm more likely to notice it. But if a film is just science fiction and says we're science fiction and mentions like a wormhole or something, like Star Trek Deep Space Nine, the TV series, had a wormhole as a big feature. And I don't think like, oh, that's not a realistic wormhole. That should be greater mass. It's too close to the spaceship or something like that.
Hmm.
I'm kind of mindless about it.
Is there any movie that you just couldn't watch? I think Neil deGrasse Tyson told me that he can't watch Gravity. Is there any movie that you've sat through and thought I can't watch that just because of the science and the theory he was trying to portray and just got wrong?
Well, I haven't seen it recently. I don't know how I'd react now, but in the 1970s, so we're talking about a long time ago, Walt Disney made a film called The Black Hole, which was supposed to be about a spaceship traveling to a black hole. And it was just, you know, completely strange. It was trying to pretend that a black hole was a place where you discover your purpose. And if you're an evil person, then you get, thrown into hellfire. But if you're a good person, you might survive. And all this stuff that had nothing to do with black holes. And I remember even at the time when I saw it, I was a child. I saw the film, and I was like, "Oh, this is really ridiculous. How call it something else, but don't call it a black hole."
Yeah.
So I don't think I walked out, but I think I remember thinking it was really ridiculous.
Well, we've talked a lot about, we've mentioned a few scientific heroes today. I'd love to ask you, who are some of your scientific heroes?
Um, Currently or in the past also.
Let's say of all time.
Of all time? Well, certainly Albert Einstein. I know a lot about the life of Einstein. Richard Feynman, although not so much for his personal life, but more for his
Mm.
scientific life and his charisma and attitude towards science. Um, Going back a bit, since I'm a Philadelphian, Benjamin Franklin, who wasn't born in Philadelphia, but spent most of his life in Philadelphia and was a pioneer of electricity. Um, I admire Johannes Kepler, Galileo. Uh, so there are a lot of scientists in history. And then in terms of women scientists, Emmy Noether, who was a German mathematician who made a lot of contributions towards physics.
Hmm.
And in terms of contemporaries, Penrose, I highly admire, Roger Penrose. And I admire the work, research of Lisa Randall at Harvard. Um, a lot of people.
I'm sure. Amazing. Well, thank you for that. The Before we start to wind down and let everyone listening and watching where they can check out this great book, this is a question I ask everyone who comes on the show. So, regardless of topic, whether they're a scientist or an actor or a sportsman, I ask them the same question to finish. So, right now, for Paul Halpern, what makes life worth living?
I love creativity. I love I love, being able to express myself, and I feel very privileged for having written all these books and then actually be invited to write articles. Like when the New Scientist said, editor said, could you write an article, your top 10 films about the multiverse? I was just like in ecstasy because, wow, I get to rewatch or watch all these films and write about them and offer my personal opinion. It just seemed like such a privilege to be asked to do things like that. But I also believe in a diverse life. So I don't just do creative things. I love the outdoors and music and, chatting with people and so forth. So I try to be, you know, a regular person as well as a scientist and a science writer.
Amazing. I love that answer, and I will. Not only I will link the electronic version of that top 10, but I'm gonna next when I'm in the supermarket later or tomorrow. I'm gonna see if I can find a copy of New Scientist and see if I can find it in the paper copy. And if it is in the paper copy, one day I'll if I ever meet you, I'll ask you to sign that. So for everyone listening, we've been talking about this book today, The Allure of the Multiverse. Where can these people, where can we point them to find this book and connect with you and all your other books? Where can they find? Where's the best place for everyone to head to right now?
Go to your local bookshop. If you don't have a local independent bookshop, go to a chain bookshop. If you don't have one of those, go online to one of the major online book retailers. It's available pretty much everywhere.
Yeah.
So you should be able to find a copy.
And for people who want to find more from you, is there a website? Where can we send them your social media?
Yeah, so I have at P Halpern, my first initial of my first name and then my last name. And then also lureofthemultiverse.com is the website for the book. And I have a Medium blog, and I have a website, yeah, which you can Google, phalpern.com, and that links to a science writer website.
Amazing. Well, I will make sure all that is linked in the show notes below. Once again, we've been talking about the allure of the multiverse. I thoroughly encourage everyone to go out and check out a copy. And particularly, I will say, it's the nicest cover of a book I've seen in a long time. So I'm not sure who designed this cover for you, but props to them because it's an absolutely beautiful jacket to the book. As a
Yes,
side note,
I
absolutely
agree.
beautiful.
I agree. I was really when I saw an image of the cover, I was just, really really excited about it.
Yeah. No, I know they say to never judge a book by its cover, but when I see a cover like this, I'm a sucker. I'll just go ahead and buy the book. So props to them. Paul, thank you so much for joining me on the Freedom Pack podcast today. It's been an absolute honor to host you and speak to you. And I'm very grateful for the insight you brought and the time you've given me today.
Thanks for having me on, Lewis. It's a pleasure.
Thank you so much for watching. If you enjoyed that video, please subscribe to the Freedom Pack channel and consider clicking here to watch another video that I think you'll enjoy.